Okay, so very good afternoon, everyone. Welcome to this course on control systems, DE14. And this course is being taught by Professor C.S. Shankar from IIT Madras, and I am one of the TAs for this course. My name is Jafar, and I am a PhD student at IIT Patna in the Department of Electrical Engineering. My main specialization is control systems. So, the basic agenda of these sessions is that you should be able to solve your weekly assignments, right? So, uh, after when you are joining this session, I assume that you have watched all the lectures of the week and also practiced some of the questions. You're well aware of your assignment, right? So that this will become more uh, like interacting, right? And already three of us are taking these sessions. So some of you might have attended the session on Friday. So so you cannot expect me to explain all the concepts here, but yeah, these sessions are made in such a way so that you're easily able to solve your assignments, right? Moreover, this is a beginner level control systems course. So some of you might have enrolled in this to prepare for GATE exams. Some of you have enrolled just for learning purpose, or you have the same course in your college. So, so taking that into consideration, I'll also level up. I'll also have good questions. We'll start with simple questions, and then we will keep on leveling up, right? So that those who are preparing for GATE do not feel like left out, right? So I'll take them also into consideration. Your first week is very easy. There are not many questions or not many gate related questions in general, but still, some of you were from ECE background or even from EE background, so you get sometimes questions based on this causal and non-causal systems, linear or nonlinear systems, time variant or time invariant systems. Even though in your assignment there are, I think, only questions based on linear and nonlinear or time variant and time invariant systems, but you have learned all this. So I'll cover all of these systems, how you can identify whether a system is causal or non-causal, linear or nonlinear, time variant or time invariant. Then afterwards we have Laplace and inverse Laplace transforms. We'll see some good questions, and afterwards, finally, before concluding, we have some applications of Laplace transform, which are very, very important, both from learning point of view or from gate point of view. There are many, many good questions that we'll be doing or seeing in this class today. So initial value theorem or final value theorem, and at the same time, we'll see how we can use Laplace transform to solve differential equations, because normally differential equations are very complicated to solve, but using Laplace transform, we can easily convert them into algebraic equations, and then it will be easier for us to solve them. Okay. So that was a brief introduction. If anybody of you have any question during the class, or just raise your hand or let me know. I try my best to answer. Right. So let's start. See, the first type of questions we'll do is we'll check, we'll see how to check whether a system is causal or non-causal, right? So let's solve. So we have this question number one, which has two parts, which is asking us to check whether a system, how to check whether a system is causal or non-causal, right? So let's take, for example, question number one, which is y of t is equal to x of minus mod of t. So basically, you have to check whether this system is causal or not, where xt is the input and yt is the output, right? And you know, a causal system you have learned. So a causal system is a system whose output depends on the present or the past values of input, right? So if that is not the case, then the system is non-causal. So we'll see how do we check that, right? So we'll just put in the values of t. So for example, let's put t equal to 1 and see what happens to the output. So when t is 1, we have y1 is x of minus mod of 1 is 1. So we have x of minus 1. It means for x at minus, for the output at 1, we should know the information of x at minus 1. It means the output at 1 is dependent on the past input, right? So it means the output at 1 is dependent on the past input. That's minus 1 in this case. So, okay, for the time being, it's causal because the output depends on the past. But we need to check at some other points as well. So normally I'll give you 5 points where you will check 1, minus 1, 0, minus half, plus half. When you have a continuous signal, if you have a discrete signal, you only need to check at 3 points. That's 1, 0, and minus 1, right? So now let's see at t equals to be minus 1. So at t equal to minus 1, we have y of minus 1 is equal to x of minus 1. When that will come out from mod, that will again be 1. So it means our output at minus 1, it depends on the input at minus 1. So it depends on the present value of input. Correct? As of now, again, it's a causal system. Now let's check at 0. T equal to 0. We have y at 0. That is equal to x at 0. So it means, again, the output is dependent on the present value of input. Now let's check at t half. So what is y half? Y half is x of minus 1 half. So it means my output at y half is dependent on my input at minus 1 half. So it means my output is dependent on the past values of input. Again, no problem. System is still causal. Now check at minus 1 by 2. So my output as minus 1 by 2 is equal to, again, minus 1 by 2. So we have checked for 5 points. We have seen our output depends either on the past values of input or on the present values of output. When that is the case, the system is causal. It means system is causal. Right? So your causal system depends, your causal system, for a causal system, your output depends on either the present values of input or the past values of input. Now let's see another question. Part number 2, which is the output yt is related to input as minus t squared, right? So again, we'll check whether this is causal or not. You also start solving with me. First, let's check at t equal to 1. So what will happen? At t equal to 1, we have y1 is equal to x of minus 1. It means my output is dependent on the past values of input. Now let's check at t equal to minus 1. My output at t equal to minus 1 is dependent on, again, the past values. Because minus 1 square is plus 1, and there's a negative sign. Now let's check at t equal to 0. So your output at t equal to 0 is x equal to 0 is equal, means it depends on the present values. Now next is t half. Your output at t half is equal to minus 1 by 4, right? So what does it mean? It means it's dependent on the past. Now tell me on this. When my t is minus 1 by 2, what is my output? What is my output? My output is, yes.
So it's basically minus 1 by 4. So it's
Yeah. It's how
in the
much?
future.
So minus 1 by 4 means 0.25. So here I can just simplify it. Minus 0.5 is equal to x of
Okay.
minus 0.25. Now tell me, is it dependent on present or past? This one at t equal to minus 1 by 2.
So it's neither, because minus
Future.
is lower than minus.
It depends on future.
Future.
Yeah. Yes, sir. It's future.
So then what is the system? Is it causal or non-causal?
Non-causal. Non-causal. Sorry.
System is non-causal. There are very simple questions. Even in gate level, you're asked of the same level. You just need to check. Now, one very important thing which you need to see is some of you who are from ECE background, I'll just write a star here. So if you are given y of like this, y of n is equal to x of the same question. Y of n is x of n squared, but the brackets are this log brackets. So it means the system is now in discrete time. So in continuous time, I was putting in values 0.5, 0.25, I can put any values. But in discrete, that's not the case. It depends on the sample time, right? So you will have integer values, right? So here you will check at n equal to 1, n equal to minus 1, and n equal to 0. No decimal points here, right? So now let's see for the same value, y at 1 is equal to x at minus 1. So, okay, it means it's dependent on past. Y at minus 1 is dependent on x at minus 1, dependent on present. Y at 0, x at 0, present. If you see the same question in continuous time is non-causal, and in discrete time it's a causal system. So be very careful while checking or while seeing whether they are asking in discrete time or continuous time. So here the system is a causal system. So more details about discrete and continuous, maybe you'll learn, yeah, or either you have learned. But for the time being, just remember, in continuous time, your time takes any value between two instants, but in discrete, you have fixed time intervals. Okay. So they were the two questions related to causal and non-causal. I don't think there is any question in your assignment about this causal and non-causality of the system. But again, for the completeness, and maybe sometimes somebody who's from EC, these questions are asked from gate. So very simple. You just need to put in values of time. For continuous time, check at 5 points. So it's quite possible that students will make mistake here at checking at these points, because somebody will check at 1, -1, 0, done. It's a causal system, but that's not the case actually. Okay. Now, second thing is about the linear and nonlinear systems. Okay. These are the second type of questions that we have. Probably you have 1 or 2 questions based on this, where you have to check whether your system is linear or a nonlinear system. So how do we check it? Right. So we are given 4 questions. We'll see all of them, which of them are linear or which of them are nonlinear. So you have learned your linear systems. If your system is linear, then that satisfies the property of superposition and homogeneity. Right. Now we'll see how do we apply. How do we check mathematically? This is fine, but how do we check mathematically? We'll see. Now let's take for this, for example, part 1, which is y of t is x of t whole squared. Okay. So I'll just write for you. Okay, from a different color, a system with input xt and output yt is said to be linear if it satisfies superposition. Now I'll tell you how. What is superposition? How do we check it? So if it satisfies superposition, now what does superposition mean? For arbitrary inputs x1 of t and x2 of t, if x1 of t leads to the output y1 of t and x2 of t leads to the output y2 of t, then x1 plus x1 of t plus x2 of t should lead to y1 plus y2. This is your superposition, and your homogeneity is EITY. If for input xt, if output is yt, then okay, like this. Then for an arbitrary scalar, a, the output should be ay of t. So very simple. So basically, when you have to check whether a system is linear or not, what you do, you take 2 inputs, x1 and x2, and see what's the output. For x1, it will be y1, and then for x2, it will be y2. Then you take the combined effect of that. So you take another input, which is x1 plus x2, and see your output, whether you're able to see your output in terms of y1 and y2. If that is the case, if x1 plus x2 produces output as y1 and y2, then your system satisfies superposition. But that is not the only thing you need to check. You also need to check homogeneity. And what does homogeneity mean? You scale up your input. For example, if your input is X and output is Y, you scale up your input X by some scalar A, your output should also be scaled by that scalar. Right? Now let's see first question. So this is our first question. I'll go with this. I'll go by the same process. So see, for x1, we have y1 of t. Okay, so when I take x1, so I get y1, which is x1 of square. Then for x2, it should be y2, which is x2 of t whole square. Now what I have to do, I have to take the combined effect, x1 plus x2. So that, let's assume that is y3. So what will be y3? It will be I'm putting values here. So it is x1 of t plus x2 of t whole square, right? Now tell me, what is this? It is x1 of t square, sorry, whole square plus x2 of t plus there is some additional term, 2 into x1 of t into x2 of t. I've just opened the formula. Now tell me whether y1 and y2 is equal to y3 or not. Like I gave x1, it produced y1. I gave x2, it produced y2. Now x1 plus x2 was supposed to produce y1 plus y2. That's okay. This is y1 and this is y2. But there is something additional. It means, what does it mean? It means when I gave x1 plus x2, it did not produce y1 plus y2. I'm skipping t for the time being. So that means your system does not follow superposition. It means the system is not linear. You need not check homogeneity because both these conditions, they should be satisfied. Then and only we can say the system is linear. So if your system is not following superposition, then even if it follows homogeneity, you need not check that. So this part is not linear, or it's non-linear. Now let's see question number 2. Please mute yourself. Now let's say this question. Again, let's take x1. So for x1, we'll get y1. That will be t, x1 of t, plus, oh, sorry, here it should be dt. So that will be dx1 of t over dt. Similarly, your y2 should be dx2 of t plus t by dt of x2 of t. Now I'll take x1 plus x2. So x1 plus x2, and I'm naming that as y3. My y3 of t is t x1 of t plus x2 of t, because for x, I'll replace it with x1 plus x2 plus d by dt of x1 of t plus x2 of t. Okay, so now I just evaluate this. It will be t of x1 of t plus t of x2 of t plus d by dt of x1 of t d by dt of x2 of t. Now see, this one and this one makes it y1. Similarly, this one and this, it makes y2. It means when I gave x1 plus x2, I got the output as y1 plus y2. It means superposition is satisfied. So as of now, we can say the system is linear, but we also need to check homogeneity, right? So now let's check homogeneity. So for xt, what did we have? We had yt is equal to tx1 of t, sorry, plus d by dt of xt. Now we are scaling it. Okay. Somebody has raised his hand. So if you have any question, please unmute yourself and ask. Please unmute yourself and ask. So now what I'll do, I'll just scale the input. So I'll scale it by axt. So what will I get? I'll get yt is equal to t into a of xt. I've just scaled xt by a of xt plus d by dt of a of xt, which I can rewrite as, I'll take a outside, a will be t of xt, and this a I will also take common, so it will be d by dt of xt. So this is here yt. This is yt. It means when I scaled with the magnitude, the scalar a, my output also got scaled by the same magnitude. It means my system is following homogeneity property as well. What does it imply? It implies my system is linear. Now tell me, somebody has any question, please tell me. Somebody is saying, sir, why you combined x1 plus x2? You can separate x1 square plus x2 square. Where? And for someone, screen is not visible. I'm not sure. So for others, I think it's visible. Please check your internet and see why I did not combine what I said. X1 plus x2. If you're asking about question number 1, so what I said, in order to check whether a system is linear or not, you need to check. Okay, you need to check. It's better if you unmute yourself and ask, because it's not clear what you exactly want to ask. So in order for us to check whether a system is linear or not, you need to check whether it satisfies superposition and homogeneity. Now, what does superposition mean? Superposition means if I have an input x and an output y, for any arbitrary input x1, if I get output y1, and for any other input x2, I get output y2, then for the combined effect of x1 plus x2, I should get y1 plus y2. In the first question, I did that, but if you see here, this x1t plus x2t, it should I'm replacing this xt with x1 plus x2, and the combined effect should be y1 plus y2. But that is not the case, because if you evaluate this, there is some this extra 2x1 x2, right, which is not in y1 and which is not in y2. It means your combined input x1 plus x2 does not produce the output in the form of y1 and y2. It means your system is not satisfying this superposition property. Okay. Now now everybody try question number 3. It's very easy. See, when you are at this stage in your second year or in your BTech, or we have just started the course, you need to solve these questions like in the elaborative way. But once you practice enough number of questions, then you can straight away say, I can straight away say by looking at the questions whether they're linear or not non-linear, right? So now everybody solve question number 3, like third part, and tell me whether it is linear or non-linear. If superposition is not satisfied, no need to check for homogeneity, right? Just tell me whether it's linear or non-linear.
Non-linear.
How?
So if we take y1, it's x1 plus 1, and y2, it's x2 plus 1, sir. When we add
Good.
both, we get x1 plus x2 plus 2, sir. But the
Very
system
good.
is we are getting an output plus 1 to the input, sir. If we give an input, the output is plus 1, sir. So if we give an input as x1 plus x2, the output will be x1 plus x2 plus 1, sir.
Perfect. Perfect. Good.
So
Very
it's
good.
not equal to, so we can say it's not linear.
So should I solve it, because or it is clear to everybody? So anyone who has not understood this, because he explained in a perfect way. So anybody who wants me to solve this question, yeah, please go ahead and ask. Shamita, you're asking something. Please ask. So you want me to solve it? If you want me to solve it, just unmute yourself and say, we have not understood it well, and uh, please
I
solve it.
didn't understand.
Okay, fine. So let me solve it. What was the question? XT plus 1. See, so what I told you, you need to first check superposition, right? For superposition, you'll take 2 arbitrary inputs. For example, here I'll take x1 and x2. Right now, when my input is x1, what will be my output? Let's assume that is y1. So my y1 is x1 of t plus 1. Right now, my y2 is, just replace x by x1 and x2. That's it. Nothing else. Fine. My y2 is x2 plus 1. Now, what I need to do, I need to replace x by x1 plus x2. Now, what, and that output I am naming it as y3. So my y3 is, in place of x, I need to put x1 plus x2. So I will put x1 plus x2. And there is this plus 1. Correct? Now my
Yes, sir, I got
y3,
it.
yes. Yes, yes.
I got it.
Okay, good.
Understood.
Now tell me, is it linear or non-linear?
Non-linear.
Yes, very good. So it is non-linear. Why? Because my y3 I cannot write y3 in the form of y1 plus y2y because then there should have been another one, right? But here is only one. Okay, so it means my system is not following superposition. My superposition is not satisfied. It means my system is not linear, or it's a nonlinear system. No need to check for homogeneity. Now, if you have understood this, then you should be able to solve the last part. What is the last part? Yes. The last part is, everybody please solve this question and tell me the answer. E raised to the power t xt. Solve this and tell me. Is superposition satisfied?
Superposition satisfied.
Okay, if superposition is satisfied, then check homogeneity as well and tell me whether homogeneity is satisfied or not. Anybody?
Homogeneity also satisfied.
Homogeneity is also satisfied. Linear.
Very good. Very good. So the system is linear. The system is linear. Now, is there anyone who has not understood? I can then solve it for him. Don't be shy. It's okay. It's completely fine. I can explain it again. Just unmute yourself and ask. Okay. Okay. Good. So now then let's move on. I hope you will now be able to solve questions related to linearity and nonlinearity. Okay. Now moving forwards, we have, because they're very easy questions. The important questions will come when we solve initial value problems, final value problems, and use Laplace transform to solve differential equations or find the Laplace transform of some functions, inverse Laplace transforms of functions. These questions are very simple. So that's why I'm not investing more time in these questions. And there are not many questions in your assignment based on this. So just for the sake of completeness, I'm doing these questions. Now let's see one more type of questions, that is time variant and time invariant systems, because you have understood, you might have seen in your lectures, your professor is dealing with linear, time invariant, and causal systems, right? Whatever systems you study in this course, there will be linear, time invariant, and causal systems. So it's very important to know what a linear system is, what a time invariant system is, and what a causal system is. Right? So now we will see how we can check whether a system is time variant and time invariant. So uh, a time invariant system means, so if we, for example, we are performing Ohm's law, right? First, let's try to understand this. We're performing Ohm's law. So I performed Ohm's law today and I got V equals to IR, or V by I is constant. Then I'll perform it tomorrow. I'll get the same thing. Then I'll perform it day after tomorrow. I'll get the same thing. I'll perform it after 1 month. I'll get the same thing. So it means this is time invariant. So irrespective of when I perform this experiment, I'll get the same answer, right? So these systems are called time invariant systems. And if that is not the case, then the system is time variant. Now, how to check? Mathematically, there is a method. Like I told you To check linear systems or nonlinear systems, you need to check whether they follow superposition or homogeneity. Similarly, for time variant and time invariant systems, there is a rule. Now, I'll make you understand that by taking question number 3, part number 1. So we have yt is equal to t of xt. So while looking for this time variancy or invariancy, what you do, you start with step 1, which is delay xt by xt minus t naught, right? Or delay xt by t naught. So it means what I get, my yt, if I delay xt by t naught, then my yt is t into xt minus t naught. Just delay xt by t naught, right? Then your second step is replace t by t minus t naught. Okay. Now do the same thing. So I'll get yt minus t naught is equal to t minus t naught xt minus t naught. Let's assume I'm keeping it equation 1 and I'm keeping it equation 2, right? So then you need to check the RHS of equation 1 and 2. If the RHS, right? So if 1, like considering RHS, if 1 is equal to 2, then my system is time invariant. If my 1 is not equal to 2, then my system is time varying, time variant. Now tell me, in this case, what is the system? Is it time varying or time invariant?
Time varying.
Very good. It's
Time
time
varying.
varying. Now with this in mind, solve question number 2 and tell me the answer. It's very easy.
Time variant.
Variant.
Question number 2. What is question number 2? Time variant or time invariant?
Time invariant.
Anybody else getting time invariant?
Time invariant.
Invariant.
Okay, anybody else? Anybody getting time variant? Okay, this is time invariant. Very good. Somebody has shouted something. Oh, okay. Gagan Preet Kaur. You have not understood then. Um, should I solve it for you? Or if you can try question number 3. Please try question number 3 as well and tell me. Your question number 3 is then if, if we don't get sufficient number of correct answers, then maybe I can solve. Yes, now please solve it. Tell me whether it is time variant or time invariant.
Time invariant.
Okay, okay. Anybody else?
Time variant.
Sorry, I'm not able to understand whether you're saying time variant or time invariant. It's also time invariant. Now, maybe some of you are, yeah, okay. Some of you are not able to understand it or they have not understood it. I'll just solve question number 2, part number 2, then maybe it will be more clear to them. So what I said, you just delay xt by t naught. So it means xt by t naught means then we get this. So in our part number 2, what we will get, yt is x of t minus t naught plus 1. Keep it equation 1, then replace t by t minus t naught. So what I get, yt minus t naught is equal to x t minus t naught plus 1. That's it. Then you compare. If RHS of 1 and 2 is equal, it's time invariant. So since 1 is equal to 2, it implies the system is time invariant. Okay, have you understood it? Anybody has any doubt? Because now we will just level up and do some hard questions. So if you have questions until here, please let me know.
No, sir.
Okay, now solve this question. Everybody solve this question. So for a system, if the input given is, or if the given input is xt is equal to cos of 2t, the output is, then the output is yt is equal to 5 cos of 2t plus pi by 3. Now tell me, what is the system? Is it, so you need to check for linearity, so whether it is linear or non-linear, and you again need to check whether it is time variant or time invariant. It's a very good question, and these type of questions are asked in GATE. You should be able to solve this question. Okay, we have another question after this. I'll give you a hint. So I said, so we'll check for first whether this system is linear or not. So for linearity, we need to check superposition and homogeneity, right? So we have given input, given that input is xt cos of 2t. Now yt with this input is 5 cos of 2t plus pi by 3. Now, one hint I'll give you, you need to represent this output in terms of input xt, right? So the output equation should have something cos 2t plus something cos 2t plus something whatever minus something cos 2t, right? So your output should be in terms of input only. So in that case, what you should do, just evaluate this expression cos of a plus b, right? So then what you'll do, solve with me 5 as it is. This is cos of 2t. What is cos a plus b? Cos a plus b is cos a cos b minus sin a sin b, right? So cos 2t cos pi by 3 minus sin 2t into sine pi by 3. You know, you can easily convert sine into cos, but before that, you know, cos pi by 3 is 1 by 2, and sine pi by 3 is root 3 over 2. Okay, then just let's then solve it a bit, or we can write it y over t is equal to, just multiplying 5 with 1 by 2, it will be 2.5 cos of 2t minus 2.5 into root 3 sine of 2t. Anybody has any doubt until here? Right?
No.
Now what we will
No, sir.
do, I told you to write sine, to write this output in terms of input. So what we will do, we will write this sine again in terms of cos, right? So can I write like this? Y of t is equal to 2.5 cos of 2t minus or plus 1.25 into root 3 cos of it d by dt of cos of 2t. Can I write it like this? Because if I differentiate it, it will be minus sine of 2t multiplied by 2. Okay, so that's what I took care of. Right? Now tell me, see, I can write it like this. Yt is equal to 2.5 xt plus 1.25 into root 3 d by dt of xt. Now you solve it. Now from here you solve it. I made it easier for you. Now you solve it. Now tell me. Now what you need to do, just put in x1, x2, x1 plus x2, see whether superposition is satisfied, and after that check homogeneity and tell me whether the system is linear or not. Now it's very simple from here onwards. I take x1, I get y1 of t is 2.5 x1 of t plus, you can just multiply this term. I don't have calculator with me, so I'm not doing any multiplication, and it will not back the answer. Similarly, your x2, for x2 you will get y2, which is equal to 2.5 x1, sorry, x2 of t plus 1.25 into root 3 d by dt of x2 of t. Now third step is very important, where you put x1 plus x2. So you should understand this, how I put this. Let's assume I'm naming it as y3. So y3 of t is 2.5. Now for x, I need to put x1 plus x2. So x1 plus x2. Again, 1.25 into root 3 d by dt of x1 of t plus x2 of t. You might have observed that sometimes I write x only and sometimes write x of t. So that means the same thing. Okay. Okay, so somebody is asking how this 1.25 has come, right? So I've written, so just solve backwards. Just solve d by dt of cos 2t. So what you will get, right? You will get sine of minus sine of 2t by 2. That 2.5, divide that with 2 and you will get 1.25. So now tell me whether superposition is satisfied or not. From here onwards, you should be able to.
Satisfied.
Superposition
It
satisfied,
is
sir.
Satisfied.
very good. So now check homogeneity. Check homogeneity.
Homogeneity also satisfied.
Homogeneity also satisfied, sir.
Very good. Now tell me, what is the system? Linear or non-linear?
Linear, sir.
Linear.
Very good. Check for time variant or time invariancy. Everybody check. Not only these two guys. Everybody check. And if you are not able to understand, tell me. I'll explain from the scratch.
Time invariant, sir.
Invariant. Time invariant.
Anybody who has doubt in this question?
So if we change the input, the system may change the what can I say, the linear or non-linear may change. So
Yes, it depends on the input.
depends on okay.
Yes. Right. So here both superposition and homogeneity are satisfied in system is linear. So time variant and time invariancy, that's not a difficult thing. You just need to replace x by t, delay x by t naught, and then replace t by t naught. You'll get the same value. So the system is linear and time invariant. So part number 1 is the answer. Okay. So here I will also write it is time invariant. Now, one last question based on this. Please solve this. Just tell me options. You need not check all the three, right? Simplest thing is to check for causality, right? So it's very simple to check whether a system is causal or not. So that's why if there are options, try to eliminate, because now you know how to solve these questions. So try to eliminate and try to save your time and tell me whether the system is, which option is satisfied.
It's a non-causal, sir.
So it's non-causal, right? Now only two options are there with non-causal. Now next thing is we'll see for linearity or non-linearity, right? So the option is only either option C is correct or option D is correct, right? So now look for linearity or non-linearity and tell me the answer.
Option B, sir.
Option B. Which option? Are you saying this option? Yes.
Yes.
Yes. That's the correct answer. Anybody has any doubt, then you can explain this question. Otherwise, you can just try it on your own. Because we have spent one whole hour on this. I think you should now be able to solve some of the good questions. related to this linear, whether the system is linear, non-linear, time varying, time invariant, causal or non-causal. Should I move forwards? Right on your own. Just write this question and practice yourself. Now let's move towards Laplace and inverse Laplace transform. See, while you're studying this Laplace, you might have watched all your lectures, but why this Laplace becomes very important in control? Because whenever you're studying control system or signals and systems, mostly you're dealing with differential equations, right? And these differential equations, they are very difficult to solve or very complicated to solve. But with the use of this Laplace transform, things become very easy, right? So that's why, or there are other applications as well. So which makes our life very simple. So I'm not going into the details of the concept and everything. You have read that. I'm assuming you have watched all your lectures. And here we are just focusing on questions, how to solve the questions, and how you can easily solve your weekly assignment, right? So, so I've written here something. So given any signal xt, that's in time domain, when we talk of Laplace and inverse Laplace, when we talk of Laplace inverse, so we talk of S domain, right? So from xt, we are going into xs, and any signal xt that can be converted into xs by simply using this integration, right? So 0 to, there is something called bilateral Laplace transform or unilateral Laplace transform, but since you'll be dealing with the causal signals throughout your course, so this also works from 0 to infinity. So this Laplace inverse, a Laplace transform of any signal xt is given by 0 to infinity, integral 0 to infinity xt e raised to the power minus st dt, right? So for example, if we have xt is equal to e raised to the power at, then what will be its xs? Xs will be 0 to infinity e raised to the power at, that is xt, into e raised to the power minus st dt. Okay. Now tell me what it will be. It will be, I'll just simplify it all using all its steps. Okay. Now tell me.
Minus 18.
Very good. Where? I've written wrong
E
in
raised to
there.
the minus 18, correct?
Okay. So it will be e raised to the power minus s plus a into
Minus S plus
t.
A.
Very good. Minus s plus a. And the limits are between 0 to infinity. Now tell me, what is the answer? 1 divided by s plus a.
1 by S plus A.
Right? So wherever you see e raised to the power at, now from now onwards, wherever you see e raised to the power at, you should know the Laplace transform is 1 divided by s plus a. Similarly, for e raised to the power plus at, the Laplace transform is 1 divided by s minus a. But there is one important thing here. See, when we wrote this is equal to 1 divided by s plus a, what did we assume? See, I'll now take this again. We are assuming this e raised to the power here is something negative. That's why that when we put infinity, it will go to 0, right? If here is this, now let's assume. So why, like how we are keeping this negative here, we are assuming our s plus a that is greater than 0. Our s plus a is greater than 0, because if our s plus a is greater than 0, then and only we can maintain this negative here, then and only our something will converge to 0. because when we put infinity, then it will be 0, and the second term will be 1 divided by s plus a. But now let's see if your s plus a is less than 0. So what will happen? So if this whole is less than 0, so it will be negative, and negative is positive. So you'll get something e raised to the power positive something. And when you put infinity, so that will blow up, that will go to infinity. Right? Are you able to understand what I'm saying? I'm saying the implicit assumption behind this answer here is that you have assumed, you yourself assumed that s plus a is greater than 0. It means this integral only gives finite value when s plus a is greater than 0, or I can say s is greater than minus a. Because if s plus a is less than 0, then we get e raised to the power something positive, and when you put infinity as a limit, that will blow up, that will go to infinity, and in that case, the value of this integral does not exist. So the region in S-plane in which the Laplace transform exists, or for which the value of this integral is finite, that is called region of convergence. I don't know whether we have studied this or not, but this is called a region of convergence. Right? So what is the region of convergence? In simple words, where the value of Laplace transform exists. And why I said S-plane, because this S is what? What is this S? When you plot it is sigma plus j omega. And I said for this integral, the ROC is S is minus, S is greater than minus A, for example, okay? So this integral only exists when the value of S is greater than minus a. So if it is minus a, then this integral only exists for this area, not in this area, because in this area the integral will just blow up. You will learn this. I just gave you this idea, or if you have not learned this after this lecture, just go through it. What is ROC and what's its role in Laplace transform? Now we never solve questions like this. Whenever we solve Laplace transform questions, we never solve it like this integral and all. Right? Because it will be complicated. If we solve it like this, it will take a lot of time. Now, what we do, we remember Laplace transforms of some of the functions, and based on them, we solve. We can write Laplace transform of any function. Right? For example, you know now the Laplace transform of e raised to the power 80 is 1 divided by s plus a. Similarly, the Laplace transform of e raised to the power minus 80 is this. Right? Now, there are some functions for which you need to remember the Laplace transform. For example, the unit step for the unit function, the Laplace transform is 1 over s. Similarly, this works backwards as well. For the unit step for 1 by s, if you take inverse Laplace, you get unit step. Unit step is 1. Similarly, if you have any function which is t, the Laplace transform is 1 divided by s squared. In general, if you take t raised to the power n, the Laplace transform is n factorial divided by s raised to the power n plus 1. Similarly, if you have sine of 80 and you have to take Laplace transform, it will be equal to a divided by s squared plus a squared. For cos of 80, Laplace transform is s divided by s squared plus a squared. This might look difficult for the moment, but once you practice questions, it's not that difficult. There are a lot of properties as well, not going into detail of every property, but we'll just go through some of the important properties. Now, this property number 6, this is very important. And property number 7 for that matter. So these are very, very important properties because we'll be using them whenever we solve differential equations, or when we study transfer functions, we'll be using these two properties. So what is this property? The property is if we have d by dt if we have dx by dt and we have to take Laplace transform of that, that is simply s into xs minus x naught. Similarly, if we have d2x by dt squared, and if we have to take the Laplace transform of that, that is s square xs minus s into x naught minus x dash of 0. This is differentiation. This is d by dt of x at 0, right? And then same is for the integration as well. Now, based on this property, let's solve one question. Okay. Okay, now let's solve let's solve two questions. One is based on Laplace transform and other is based on inverse Laplace. So let's solve question number 1, where we are given e raised to the power minus 2t. Right? So what is the Laplace transform of e raised to the power minus 2t? You know the Laplace transform of e raised to the power minus 2. Very good. So it will be 1 divided by s plus 2. Right? You know why I have kept this ut here?
0 to infinity.
Very good. So whatever I told you about the ROC thing, so that condition is being taken care by this thing. There's a causal system. It exists between 0 to infinity. Right? You learn these things because in 2 hours I cannot cover everything. Or you have to watch all the lectures in detail and make notes and then summarize questions and ask. There is a possibility. I think there is one forum where you can ask questions and get answers as well. So make sure you are not just watching lectures, because assignments, just watching the weekly lectures, you will be able to solve them. But in order to learn, because assignment is one part, you will have to write one exam, and that's very difficult. Not everybody qualifies that. So assignment, somebody will solve and provide the solutions, done. No need to solve, even if you do not attend. But for learning purpose, you should attend, because otherwise you will not be able to qualify this course. You'll not be able to pass it. Okay. So e raised to the power 2t is the Laplace transform is 1 divided by s plus 2. Now what I need to find? I need to find d2x by dt square. Right? So I told you the formula is s square xs, where xs is the Laplace transform minus s into x naught. Be careful about this. When I write small x, it means it's in time domain, right? When I write capital, it means it's in Laplace, it's in S domain. Minus x dash of at 0, right? So I know xs. Xs is this 1 divided by s plus 2. Now I need to find the value of the signal at 0. Then I need to differentiate the signal and find the value at 0. Yes, please.
Why did you take u of this function?
Again, I told you it's very difficult if I again these basic things. I told you about what is a causal signal? Not system, signal.
Yes, sir. Yes,
What is a causal signal? What is
it's
UT?
a step function.
Yes, it's a function that exists from what? Like, see, this is UT. This is T. This is U of T. Right? This is 1. So this function, it goes from, it's 0 when time is less than 0, and it's after 0, it's 1. So what you do after you finish this class, try to plot the graph of e raised to the power 2t with ut, and you'll get your answer. It makes the signal from 0 to t. Right?
Okay, sir.
Okay. So you have xs, you don't have x naught, you don't have x dash at naught. So let's find x naught. So what is x naught? X naught is e raised to the power 2 into 0, which is equal to 1. So my x naught is 1. Now let's differentiate this. It is e raised to the power minus 2t into minus 2, and find the value at 0. So this will be 2 into 0 into minus 2. So what will be the value of x dot? Minus 2.
-2.
Now let's put in the values. So d2x over t by square is s square divided by s plus 2, then minus s into 1, right? That is s, then minus into minus s plus, that's 2. That's the answer. Okay. Anybody has any question? Understood? Now let's solve
Yes, sir.
question number 2.
So if we simplify, the answer will be 4 by s plus 2. Size.
Great. Great. What's the answer? 4.
4 by s plus 2.
Okay, good. Now do question part number 2. Part number 2 is find the inverse Laplace of. You are given a Laplace transform of a function, that is s plus 5 divided by s plus 1 into s plus 3. You need to find xt. Now how to solve? Right? So now we need to go from s domain into time domain. Now see what we will do. These inverse Laplace questions are very easy. So s plus 5 divided by s plus 1 into s plus 3. So I will write it in the form of partial fractions. So because then it will be easy. Y s plus 1 plus b divided by s plus 3y. Because I know what will be the Laplace transform of the inverse Laplace of this. I know what is the inverse Laplace transform of this. I know how it is coming. Why? Because this will be something multiplied by e raised to the power minus t. This is again something multiplied by e raised to the power minus 3t. We just need to find the values of a and b. Correct? So that's why I'll just write them in the form of this partial fractions. Now, you must be aware of this thing, but still for the completeness, I'll solve it. So this will be s plus 5 is equal to a into s plus 3. If anybody has any doubt how to solve partial fractions, let me know. I will then explain in detail. Right? I just multiplied throughout. Now, in order to find the value of a and b, I'll make them 0 one by one. So first I'll make this term 0. So this will be 0 if s plus 3 is equal to 0. It implies if s is equal to minus 3. Then put s is equal to minus 3. What we will get? We'll get minus 3 plus 5. It will be 2 is equal to, this is 0, plus b into minus 3 plus 1 minus 2. It implies b is equal to,
-2.
now what you do? You make this term equal to 0. S plus 1 is equal to 0. Then s is minus 1. So put s is minus 1. It means I get 4 is equal to a minus 1 plus 3, 2. It implies a is 2. Okay? Just put the values of a and b back into the equation. We'll get s plus 5 divided by s plus 1 into s plus 3 That's now equal to 2 divided by s plus 1 minus 1 divided by s plus 3. Okay, now you know what is the inverse Laplace of this? Tell me.
2 into e
2.
power minus t
Mhm.
minus
Minus.
e to the power minus 3t.
So
E to the power minus.
these inverse Laplace questions, one thing you need to be very careful of is the partial fractions. So you should be very well versed with partial fractions, because this was an easy case. Sometimes you get a very difficult case. You get some complicated uh, uh, terms. Uh, so only you need this partial fractions and you're done. You'll easily find this inverse Laplace, right? So we still have time. So we'll go and see some what are initial and final value theorems, right? So these initial and final value theorems, they make use of Laplace transform to find the initial and final value of a function, right? So sometimes we have a function, we need to solve it, for example, a differential equation. Then you're being asked to solve this differential equation and find the value of t, find the value of y at x equal to something, anytime. It is very difficult because you need to solve it first, then again find the value. Well, it will take a lot of time. But please mute yourself. A lot of noise is coming. So, but this Laplace transform, using this Laplace transform, it is it's very easy to solve such problems. Okay. So, but there are some conditions which needs to be satisfied before you apply this initial and final value theorem. So questions from initial value theorems and final value theorems often appear in GATE, be it EC or EE. And in fact, they will come in your final exams. I don't know whether you have any question in your assignment based on initial and final value theorem, but you should not skip it. You should learn these um, like theorems in detail. So first, let's take initial value theorem. In short, I'll write IVT. So you cannot. So what is IVT? IVT helps you to find initial value of a function, right? And how do you find it? Using Laplace transform, you take limiting s tends to infinity, s into xs. So you see, this is the value in time domain. So by using Laplace transform, you're able to find the initial value in time, right? So initial value of any function can be found by taking its Laplace transform, multiplying with s and taking limiting s tends to infinity. So that's it. That's how you can find the initial value. But this is only valid. You can only apply initial value theorem if you have a proper function. If you have a, what does proper function mean? So in a proper function, order of numerator is less than order of denominator. So the functions that you have, the order of numerator should be less than the order of denominator. If that is not the case, then that does not mean you cannot find the initial value. You can still find the initial value by taking inverse Laplace, then solving the differential equation and getting the value. But that means you cannot apply initial value theorem to find the initial value. Okay. Now let's go to final value theorem. Final value theorem, what does that say? X at infinity is equal to limiting s tends to 0, s into xs. Okay, very simple. Again, the value of the function at infinity, that is equal to Laplace transform of that, multiply that with s and take limiting s to 0. But again, it's valid only if you have proper function plus there's one more condition. All the poles must lie in the left half plane. I'll explain this. With at most one pole at origin. There are many tricky questions based on this thing which are asked in GATE and other competitive exams. And what does this mean? It means my function should not be unbounded. I'll tell you this. See, in the next week, probably we will learn transfer function. And the value of transfer function, the value of the S, where this transfer function, the value of transfer function goes to infinity. They're called the poles of the system. For example, in simple words, if I have something 1 divided by S minus 1. So if I put S equal to 1, then the value of this function will go to infinity. It means my S equal to 1 is the pole of the system, right? It's pole. You also have questions in your assignment where you are asked find the singular points. Those singular points are also poles. So basically you need to find the poles. So what you need to do, if in questions where you are asked to find the singular points, you need to put the denominator to 0 and find the values of the S for which the denominator is 0. So they are the singular points, so they are the poles. Now, when we will study, maybe in next couple of weeks, when a system is stable or when a system is unstable. For the stability criteria, all the poles, they should lie in the left half of the S-plane. I told you the S-plane this is S-plane, sigma plus j omega. See, this S is a complex number. It's a complex number, so it has a real part plus j omega. It has a complex part. So this is what I'm plotting here, right? So the values of S, they are again real, they are again complex numbers. So they have a real part as well as an imaginary part. So for the system to be stable, the value of S or the value of poles or the poles should lie in this left half plane, right? Why that is the case? Because in that case, my trajectories or my solution of the system will be bounded, right? For example, take a simple example of a fan. If I turn on a fan, and let's assume the fan starts from 0, attains some speed, and then it rotates at that speed and keeps on rotating on that speed. So it means it settles down at a fixed speed. But if this fan was an unstable system, then the speed would increase, keep on increasing until it blows up. So that is a problem. So your practical systems, whenever you're designing any system or you're working on a system, that should be stable. It means the trajectories should be bounded. The trajectories with time, they should be bounded, like either this, you should go to 0. They should not be like this. Okay. So this is the case here. So why this is important in final value theorem? Because if a signal is unbounded, then you know the value is infinity. The value at infinity is infinity, because that will be unbounded. If the pole is in right half, it means the signal is unstable. The trajectories will go to infinity, so there is no point of evaluating that, right? Again, but in any case, if still you are being asked to find the initial value, and you are not asked about if you are asked to find the final value, but not about using final value theorem, you can still find the final value, even if final value theorem is not valid, because you can just take the Laplace inverse, you get something in time domain, put t equal to infinity, you will get infinity, right? So still you'll get final value, but final value theorem you cannot apply. Now there is one more important thing. I wrote it should be a proper function plus all the poles must lie in the left half plane with at most one pole at origin. So this is one flexibility that we have. Even if my all poles even if my all the poles are not in the left half plane, if one of the poles, if I have 3 poles, out of those 3 poles, 2 are in the LHP, but one is at the origin, still I can apply this um, final value theorem. So this is one flexibility. If you have one pole at the origin, then you can apply. But if you have more than one pole at the origin, or you have any pole in the left half, right half plane, then you cannot apply. Okay. So I hope you have understood this. Now let's take a look and find like solve these questions so that you'll
Doubt,
understand in a
sir.
better way. Yeah, sure.
Sir, can we have conjugate pairs so that also we can apply a
No,
final value theorem?
No.
Or only
No.
real values?
no, yes. Only one pole is acceptable. I'll answer this question more when we will study Raoult-Howitz criteria
Okay.
of finding stability, right? Then
Okay.
it will be more clear. Then we'll see. It will be more clear. I think that's in week number 4 or week number 5. It will be more clear. For the time being, the answer is no. Only one pole is allowed. So now take this question number 1. You need to find the initial and the final value using initial value theorem here. Okay. So we need to find the initial and the final value using. I'm writing here using IVT and FVT, because you can always find initial value and final value theorem. But here, the point is we need to apply IVT and FVT. Okay. So now let's solve it. First, I will use initial value theorem. So what does initial value theorem say? My initial value is equal to limiting s tends to infinity. Be very careful here. S into xs. Xs is given 7s plus 6 divided by s into 3s plus 5. This s and this s will go. Okay. Now, if you put infinity here, what you will get? Now, if you put infinity as a limit, what you will get?
We'll get
You will get
infinity,
infinity or infinity.
we need
Right?
to
Because
divide
7.
s with each terms.
Yes, very good. So that is the way we do it, because if you put infinity here, you will get indeterminate form, which is because 7 into infinity plus 6 is infinity, divided by 3 into infinity plus 5 is infinity. So what you need to do, okay, Bhargavi has solved it. That is the correct answer, but let me solve it for others. So what I will do in this case, I'll write limiting s tends to infinity. I'll take s common. So when I take s common, what I'll get? 7 plus 6 by s. Similarly, I'll take s common in the new denominator. I will get 3 plus 5 over s. This s and this s will go. Now let's put the limit. Now when you put limit, you will see this term will go to 0. Similarly, this term will go to 0. Why? Because 5 divided by a large number is 0. Similarly, 6 divided by a large number is 0. So then my answer is 7 by 3. Correct? Now, similarly, let's find the final value theorem. Yes, please. Anybody has any question? Somebody was saying something. Okay. So now let's find the final value theorem. So final value using final value theorem, that is limiting s tends to 0, s into 7s plus 6 divided by s into 3s plus 5. This s and this s will go. Then what is the answer? You put the value of s to 0. So it will be 7 into 0 plus 6 divided by 3 into 0 plus 5. Your answer is 655. Correct? So have you understood?
Yes.
Anybody has any doubt? Please start solving question number 2. Question number 2 is x of s is equal to s plus 1 divided by s plus 2 square plus 10. Very simple, very simple. I want answers from everyone this time. Write in the chat box. If you solve it, tell me what is the initial value and what is the final value. Tell me, help me. Venkateshwaran has written the initial value is 1. Okay. Okay. Wait. What have you written? The initial value is 1. Good. Bhargavi, very good. Yes, the initial value is 1. Now find the final value. Find the final value. No. Check again. No, how you can get 1 by 14? 0 divided by 14. Limit is going to 0. So something divided by, okay, let me solve it. You both are getting the wrong answers. So my infinite value will be, yes. So, okay, let me solve it. So it will be limiting s tends to 0, s into s plus 1 divided by s plus 2 square plus 10. So it will be, okay, I'll just multiply. So it will be limiting s tends to 0, s square plus s divided by s plus 2 whole square plus 10. Now see, put s to 0. It will be 0 divided by something divided by some number. It's 0. So it's not 14 or something, right? So maybe you are getting here as 14, but on the top it's 0. So it's 0. So anybody has any doubt, please tell me. If you do not have any doubt, then solve question number 3, part number 3, which is xs is equal to 4 divided by s square minus s. I think this is the question. Yes. Find the initial value and the final value of this function. Tell me. Anybody?
Initial value is
Bhargavi,
0.
very good. Very good. So what's the final value? Okay, initial value is 0. What is the final value?
-4.
Wait, just a second. So initial value is 0. What's the final value? Tell me one thing. Somebody has said, okay, Bhargavi has said
-4.
minus. Okay, okay. But tell me one thing. Did you check whether you can apply initial value theorem or not? See, this x of s is 4 divided by s into s minus 1. So my poles are s equal to 0 and s equal to 1. So this 1, it is in the right half plane. You cannot apply final value theorem here. How did you apply? It is a proper function, but it's not, the poles are in the right half plane. So you cannot apply initial final value theorem. So the system, the function is it's unbounded. Who is saying -4? Still, you are not able to understand. You cannot apply final value theorem here. Have you understood?
Yes, sir.
Yes, Shankar R. I explained this in detail that you can only apply final value theorem when you have a proper function, means the order of numerator should be less than the order of denominator. That's not the case here. So that's the case here. We have less order of the numerator is less than the order of denominator. So that's fine. But the second condition for the applicability of final value theorem is all the poles must lie in the left half plane with at most one pole at the origin. But here in this question, we have one pole at one pole is 1, which lies in the right half plane. It means the system is unstable. When the system is unstable, that means the response will be something like this. It will go to infinity. Actually, the final value is infinity. But you will not be able to find it. You cannot apply final value theorem, but you can still find the final value. How? I'll tell you. I'll just give you a hint. I'll not solve it whole. But see, x of s is 4 divided by s into s minus 1. I can write it like this: a divided by s plus b divided by s minus 1. Partial fractions. Find the value of a and b. You'll find your a is -4 and your b is 4. So it implies it is 4 by s plus 4 by -4. 4 divided by s minus 1. So it means when you take the Laplace transform of this, it will be -4 u of t plus 4 e raised to the power t. So now when you put t equal to infinity, you see it will blow up to infinity. That's why I said you cannot apply final value theorem when your poles are in the right half plane. Why? Because due to that a positive pole, you will get e raised to the power plus something, which will lead to instability and which leads to the response to go to infinity. I hope now this is clear. So if you have understood this, then solve this question. Be very quick and tell me the answer. You should be able to solve this question. Understand the question and tell me how would you approach this question? The question is, you are given a function in time domain ft, and you are given that ft is Laplace inverse of something. And then you are given if limiting t tends to infinity ft is 1, it means final value is given. So you need to find the value of k. So such questions you can expect in GATE. It's very simple. You will see the answer in 2 steps, but it's tricky to understand. So when you are reading the question, you should be able to interpret that final value is given. You have a function xs, a function final value is given. So you will apply final value theorem and you can get the answer. So I've given you a hint. Now tell me, what is the value of k? Yes, please.
That is 4 is the correct answer.
Very good. 4 is the correct answer. Anybody else got 4? Arti Kumari, very good. But let me solve it for everyone. Bhargavi, very good. So I'll solve it for everyone. It's very simple, but yet, a very, very good question. So it's given that final value is equal to 1. So you just apply final value theorem. Just apply final value theorem, right? So if you apply final value theorem, so you need to find f of s, right? So it's given, f of s is given. So this is f of s. So what will this be? Limiting s tends to 0, s into 3s plus 1. Very good, Soham. 3s plus 1 divided by, for those who have not understood, please look here. S cube 4s square plus k minus 3 into s is equal to 1. Now you see, I'll just take s common in the denominator and cancel that with the numerator 1. So I'll get, it implies limiting s tends to 0, s into 3s plus 1, here s into s square plus 4s plus k minus 3. This and this will go. Just put in the value of s equal to 0. You will get 1 divided by k minus 3 is 1. It implies k is equal to 3 minus 3. Sorry. So it implies k minus 3 is equal to 1. That's k is equal to 4. If anybody has any doubt in this question, please tell me.
So what about L inverse?
What about?
The question is L inverse.
Sorry,
The
I'm not able to
question
understand.
f of t.
Uh-huh.
The question f of t equal to L inverse.
Yes. What about that?
We didn't, we
So,
didn't took L inverse in the final
oh,
value
yes.
here.
Okay. And also Gaganpreet has asked why I wrote 1 divided by k minus 3. Okay. See, you have to identify. See, in this question, it was given that final value is equal to 1. So in order to apply final value theorem, what do we need? You need fs, right? And how will you get fs? From ft, you will take Laplace inverse of fs, right? So that's given in the question. You just need to identify. Everything is given in the question. You just need to identify. So when you take Laplace inverse of fs, then and only you will get ft. So you have to understand that that fs is given, right? Now coming to Gaganpreet's question, how I wrote 1 divided by k minus 3 equal to 1. See, I hope until this step you are okay. And now you put s equal to 0. When you put s equal to 0, this term will be 0. So you will get 1 here. Then this term will go to 0. This term will go to 0, and you will get this term here. So when you put the limit, you get 1 here in the numerator and k minus 3 in the denominator. That's how I wrote 1 divided by k minus 3 is 1. And yeah, I hope this answers your question. Now, before we end, let's solve this question. Okay, I think this is from your practice assignment. You have a similar question in your assignment. Now try to understand. Consider an LTI system where the governing equation is this. So I was talking about in the beginning that differential equations are very difficult to solve. So this is the differential equation that you will encounter frequently in this course. So differential is a second order differential equation that's given. And in the question, it's given that take initial conditions as 0 and assume unit step is applied. Then there are some questions. Then the value of output as time tends to infinity is. Now see, this first question, what is it asking? It's asking find the final value of the function. Very simple. It's asking find the final value of the function. There are two ways of doing it. One is to apply final value theorem. Second is to solve it in time domain, right? Take the Laplace inverse, get the time domain function, then put t equal to infinity, right? So here, if you see second question and third question, they are based on the same thing. They are actually based on second question and third question. It means the questioner, like the instructor is asking you to evaluate it by taking inverse Laplace, because when you take inverse Laplace, you will get the function in time domain. So then and only you will get the terms like e raised to the power t or e raised to the power minus 4t, right? So now pay attention. How else? So I will solve it using final value theorem and using this inverse Laplace both. So then we will compare the answers, right? So what is given? The given is the dynamics are given by y double dot of t plus 5 y dot of t plus 4 y of t. Now we will use Laplace transform to solve these equations. I told you it that becomes very Laplace transform comes handy while solving these equations. Now I told you the recap. D by dt of xt is equal to s into xs minus x naught. Similarly, d square xt by dt2, if I have to take Laplace transform, so it's Laplace transform. So what is it? It is s square xs minus s into x naught minus x dash of. So we studied this thing. Now, if you see in the question, it's given take initial conditions as 0. Take initial conditions as 0. So it means this part we need to take 0. Similarly, this part we need to take as 0. This part we need to take as 0 because they are the initial conditions. They are coming from initial conditions. It's given in the question, take initial conditions as 0. That means my dx by dt will only be s into xs. Similarly, my d square x by dt square will only be s square xs. That's it. Now just apply these two things here. Just apply this here. Now see what's the answer we'll get. We'll get y double dot t will be s square ys, because these terms will be 0. Then plus 5 into y dot will be s into xs. So we will get 5 into s into ys plus 4 into ys is equal to u of s. I did nothing. I just transformed. I just took the Laplace transform. That's it. Right? Now what I will do, I'll take ys common. So I'll take ys common. When I take ys common, I'll get s square plus 5s plus 4. And here I'll get u of s. So then I'll find ys. Ys will be u of s divided by s square plus 5s plus 4. Okay. Again, it's given in the question. Again, it's given in the question. Assume unit step is applied. It means I'm applying unit step. So I told you u of t, the Laplace transform is 1 by s. Okay. So I will write this equal implies my y of s. I'll just replace this u of s by 1 by s. So it will be 1 by s into s square plus 5s plus 4. Okay. So now this I can break. I can just break it. There are many ways to break it. So I can write it as y of s is equal to 1 divided by s into s plus 1 into s plus 4. I have broken this into s plus 1 into s plus 4, right? You know how to do that. You split the middle term or you factorize the constant term, and there's a well-defined procedure for that. Now you got the value of ys, right? You got the value of ys. Now what you will do? If you have to find the final value, what you will do? You can use final value theorem, right? So if there would have been only one question, find the final value, then things were easy because you will see whether I can apply final value theorem or not. So first check the order. Okay, order of numerator is less than the order of denominator. Fine, first condition is satisfied. Now check the poles. The poles are s equal to 0, s equal to -1, s equal to -4. Okay, the poles are in the left half plane with one pole at the origin. I think that's fine because I told you I can admit at least one pole at the, if there is at least one pole at the origin, that's fine. I can still apply final value theorem provided the other poles are in the left half. So well and good, we can apply the final value theorem. So apply final value theorem. So it means y at infinity is equal to limiting s tends to 0, s divided by s into s plus 1 into s plus 4. This and this will go. It means I'll get, just put the value, it will be 1 divided by 0 plus 1, 0 plus 4. It means I'll get the answer as 1 divided by 4. That's it. So if I would have only, if the question would have been that find the final value, so I can use anything. I can use final value theorem if I can apply, or I can now show you another way. So by using final value theorem, we got this 1 by 4. Now see, I can now do in another way, which is a bit complicated, but the question demands us doing that. So we had ys is 1 divided by s into s plus 1 into s plus 4. Now what we will do, we will take inverse Laplace of this. When we take inverse Laplace of this, we'll get the signal in time domain, right? It means how I proceed, 1 divided by s into s plus 1 into s plus 4 is equal to a divided by s plus b divided by s plus 1 plus c divided by s plus 4. Correct? Now, if you solve it, you will find the value of A, you solve it, you will find the value of A as 1 by 4, value of B as minus 1 by 3, and value of C as 1 by 12. Then it means Y of S is equal to 1 by 4 into S minus 1 by 3 into S plus 1 plus 1 by 12 into S plus 4. Okay, so now it's very simple. What you have to do, take inverse Laplace. So when you take inverse Laplace, we will get yt is equal to 1 by 4. This is what? 1 by S is 1, unit step, minus 1 by 3. This will be e raised to the power minus t plus 1 by 12 e raised to the power minus 4t. Right? So now you have to find the final value. Final value means you have to find the value of t when t goes to infinity. So now y at infinity is equal to, I'll put here, it's 1 by 4 minus, this will go to 0 because this is minus t. Similarly, this will also go to 0. So it means my y at infinity, even if I did by solving from the inverse Laplace, I also got the same answer, which is 1 by 4, and which we got from the initial value theorem. Now the other question is, what is the coefficient of e raised to the power minus 4t, and what is the coefficient of e raised to the power minus t? Okay, so now first tell me 1 by 4 is what? So the value of output as time t tends to infinity is 0.25. So 1 by 4 is 0.25. So option A is the correct answer. Now we need to find the coefficient of e raised to the power minus t. So see, this is e raised to the power minus t. And what is the coefficient of e raised to the power minus t? Minus 1 by 3. And what is minus 1 by 3? Is there any option? Is there any option? Yes. Minus 1 by 3 means this option, 0 minus 0.33. Similarly, what is the value of, what is the coefficient of e raised to the power minus 40? The coefficient of e raised to the power minus 40 is 1 over 12. If you do 1 over 12, you will get the value as 0.083. Right? So you have a similar question in your assignment where they ask you to find the final value and also ask you some other questions. So I hope you have understood this. So what you basically do, you approach the question by first properly reading it. It's given in the question, take zero initial conditions. So you'll take zero initial conditions. And after that, it's given that you'll apply unit step input. So take ut as 1 by s. And after that, just take inverse Laplace and solve it. So after taking inverse Laplace, you'll get this expression in time domain, and then you're done. Right? So that's it. I think now you will be able to solve some of the good questions and all of your assignment questions. Thank you very much for attending. If you have any questions, please ask. Any book? Yes. Please ask.
In previous sums that I had, how to find the pole
How to find the poles?
in second question, previous sum.
In previous question, which? This question?
Before
Which
sum.
question? Before
Before
this.
this. Yes,
This
sir,
question?
one.
Okay, good.
Yes.
So for this third part,
Second question, second round.
this part,
Yes, sir.
very good. So see, there are two ways to do it. First, you can evaluate this expression. So basically, you need to find the value of this S for which this whole will be 0, right? This whole term, this will be 0. So what you will do, you will just go this s square plus 4 plus 10 plus 2 plus 4s, right? Okay. So then what you will do, you will write it s square plus 4s plus 14. Then this is a quadratic equation. You can find the roots. Is that okay?
Yes, sir.
The roots of this quadratic equation will be the poles of this system.
Okay,
Okay.
sir.
Yeah. Anybody?
Yes.
Okay. Somebody is asking any book you suggest for practice. I would recommend. See, there are many books, but it's better if you get some previous year gate booklet, right? Because then you can solve quality questions. You know, try to see previous year that question booklet and try to solve whatever topic you study. Try to solve those questions. And yes, there are some books like I don't know what are the reference books they have suggested, but yeah, there is Ogata. Ogata is a very good book, and there is Norman and Nice as well, which you may refer to, or M. Gopal as well. So, but prefer if you're preparing for GATE or any good competitive exam, then you should solve good questions, right? And attend these sessions regularly, and then solve some of the previous year questions, and I think that should be sufficient. Anybody else? Anybody else has any question? Okay, I'll just write. If you would need any book, I did teach another similar course in the last semester. So for them, I did provide some of the books to them. So if you need any books, just drop me an email on this. I can send you the books. So I'm just stopping the recording. If anybody has any questions, please let me know.